Welcome to the GPT-5 Build Hour. I'm Christine, I'm on the startup marketing team, and you might recognize Bill from our Image Gen Build Hour.
Hi, yeah, it's good to be back again.
So Bill had so much fun last time that he brought a few of his friends.
Hi, I'm Eric. I'm from the post-training research team.
So if you're new to Build Hour, the goal of Build Hour is to empower you with the best practices, tools, and AI expertise to scale your company using OpenAI APIs and models. Next slide. Below, you can see our homepage, so feel free to visit this for any upcoming Build Hours. We have one on September 3rd that's going to be all about Codex. But for this one, we are going to be talking about our smartest, most steerable model yet. I dropped these two links in the chat for you to open up, and feel free to test these out as you're following along. Highly recommend looking through the prompt optimization cookbook as well as the prompt optimizer. We want to help you build better with GPT-5. You might be looking a little bit like this with some bad prompting, and our goal is after this hour for you to look a little bit more like this. So feel free to use any of the questions in our chat as we go through, because we'll be answering them live. Next slide. So here's a snapshot of what this next hour will entail. First, we'll be talking through the GPT-5 new capabilities. So we're going to touch on coding, agentic tasks, and some new features. We won't spend too much time on this because then we'll be diving straight into demos, specifically using GPT-5 in the Responses API. And then we'll spend 10 minutes on prompting, covering best practices, as well as meta prompting and walking through what that looks like. And then we will welcome Riley, the founder of Charlie Labs, on stage to share how he built an autonomous coding agent with GPT-5. And then, as I mentioned, Q&A. This is your chance to get your questions answered. We have our team here in the room with us answering these as we go along. And then we'll also select a few to address live towards the end of the session. So I will pass it off to Bill and Eric.
Awesome. Thank you, Christine. It's good to be back again. We have a lot of content prepared, so a lot of those things I'll touch upon in a demo. So I'm just going to run through the deck really quickly just to show you what the GPT-5's capabilities are. GPT-5 is a true coding collaborator. I think that there's no question about it. I think there's already a lot of news and hype in the media these days, and I'm happy to confirm that these are true. This model does show is a step function increase in code quality, in its ability to create a good-looking front-end UI. It's also incredibly collaborative. It's also really steerable as well, so you can tell it what to do, and it'll be able to do things for you. Couple of benchmarks, since people seem to really care about benchmarks, but bigger numbers always better, and I'm happy to say that's right. Indeed, we have like bigger numbers on important benchmarks like SweetBench, as well as Ada Polyglot multi-language code editing. Not only is GPT-5 good at coding-related tasks, it's also very good at long-running agentic tasks as well. So what I mean by that is agentic tasks that involve long chains of tool calls. So if you want the models to be able to do things end-to-end by itself, by calling tools, GPT-5 is going to be able to do that. Also with instruction following as well, so it does exactly what it's told to do when conditions arise. And it also provides pretty good explanations of its actions up front through its preambles, and also proactively corrects itself if it finds itself going down the wrong path as well. A couple of other new features. We also, with the GPT-5, introduced a new reasoning parameter called minimal. So this GPT-5 is a reasoning model, but with minimal reasoning, GPT-5 essentially does the least amount of reasoning it needs to do. And so at the end of the day, you get the intelligence of GPT-5 alongside the increased model intelligence with the latency profile of a non-reasoning model like that you're familiar with, like GPT-4.1. Custom tools as well, so you don't have to worry about escaping JSON. So what this allows you to do is make tool calls in plain text. So if you're building something in the agentic coding space, you don't have to worry about escaping finicky JSONs anymore. Verbosity parameter, pretty self-explanatory. it steers how much of a final output you want out of the model. But I'll also talk a little bit more on the tips and tricks on how you can use this for function calls as well. Without further ado, let's take a closer look at GPT-5 inside of the Responses API and how you can use it. So here I have a my cursor pulled up with the OpenAI build hours repo. And just to give you guys a quick show of like its improved front end capabilities, I ran a one-shot inside of Cursor using GPT-5 right before this build hour. This is create another folder named landing page and generate a landing page of a AI coding product called Vibe Coder. Very, very simple prompt. And you're able to see that it has generated a fully functioning website alongside of tabs that just works. So this is pretty much a tangent here. I just wanted to show you the cool things that you're able to build out of the box. Now you might be wondering, how are you able to build something like Cursor with GPT-5? Now this is what I'll be getting into, like how you can use GPT-5 inside of the API. So inside of API, to use GPT-5, very simple. All you have to do is change out the slug. You can see here in the Responses API, I have the model that says GPT-5. And all of a sudden, like this request is hitting the GPT-5 model, and this comes from the GPT-5 model. And just to show you the minimal reasoning effort as well, here I have two identical requests that's been sent to the model. One of them finished in 0.9 seconds. The other one finished in 6.9 seconds. On the first, we use minimal response. The second, we use high reasoning effort for the response. And as you can see, there is a difference in how long it takes for those two things to come back. And also on the second part, I also turned on reasoning summary as well, so you can see exactly how the model reasons.
Yeah, so Bill, like you've been talking a lot, there's this like responses thing here. Can you tell us more about that?
Oh yes, Responses API allows you to really use GPT-5 to its fullest extent. If you are familiar with our, let me just run a couple of cells here so you can see to generate the things that I'll be talking about shortly. If you are familiar with our API, in the early days, back in the GPT 3.5 turbo days, we created this thing called Completions API, which is what most of you guys might be already familiar with. So as you can see here, we're using the Completions API saying hello world, and here we're using Responses API to do the same thing. Those two APIs, Responses API is essentially kind of a V2 version of the Completions API. It's a better and more feature-rich version of the API that really allows you to take advantage of the full capabilities of reasoning models like GPT-5. On the surface level, they look kind of similar, just with additional developer experience affordances out there. So putting things like output text is a lot easier than choices, square bracket, zero.message.content that you have to get into with Completions API. But there is one thing here that I would love you to take note. If we dig into the response that it can output. So there are two differences here. This one, I didn't pass in the parameter store equals to false. Here I have by default store equals to true. So the Responses API by default is a stateful API as well. And you can turn that state off by passing in a store equals to false, and you can use something called reasoning.encrypted content to get the same benefits. And what I mean by benefit here is this thing, the reasoning item that it's passing back. If we look into the response.output, we see that we have a reasoning item. One is encrypted here if we use store equals to false. One is not encrypted. I'll just talk briefly about what this is and how we can leverage this. So for the reasoning models like GPT-5, it emits something called chain of thought reasoning tokens when it's reasoning and calling it the tools. Those are basically the intermediate steps while it's thinking, things like, oh, what tool should I be calling at this moment? Why I should be calling these things? And this is useful because for you, if you pass those things back after a tool call, the model will have access to the reasons why it's called the tools in the first place. So it's able to continue its chain of thought much more coherently. And to demonstrate this a little bit more concretely here, when is reasoning items really necessary for model intelligence? So if you just imagine you sending a message, like a user message, like I have here, like what is the weather in Paris today? the API might start to think that, hey, I don't have all of the context, and therefore I'm going to give you a tool call for you to run on your side as well. But because I'm a reasoning model, I have all of those reasoning steps that I have performed. I also want to know why I have called this tool after you have provided the response. So I'm going to give you that reasoning item so that for you to be able to pass it back to me. And when you finished with a tool call, the user, you pass back the reasoning item as well as a tool call result directly to the responses API, which then continues its train of thought in deciding whether or not it has enough context or it needs to call another tool as well. And so as you can see here, we have a tool called Get Weather mocked up, and I have the user asking what the weather is like in Paris today. And we can just take a quick look at the response. We're using encrypted chain of thought tokens here. So for ZDR orgs that cannot use the statefulness of responses API, we give you the chain of thought tokens encrypted inside of this encrypted content. As you can see here in responses, we see that all of this is present. And as we see also here, this tool call is emitted with the arguments of longitude and latitude of Paris. And as the user here, what we can do here, all we have to do is add this whole thing to the context. You don't have to worry about parsing out the encrypted content or the reasoning item. And then we can mock up a response to how much Paris is actually hot or cold today. And you can see here, this gets back to us with an answer. This is a very simple toy example, so it might not inside of completions, you will probably get the same answer. But for a long-running agentic task where you have 20 to 50 tool calls back to back, this can really mean the difference between 2 to 4% difference in benchmarks like Sweetbench.
Yeah. So Bill, just to summarize here, the model is going to perform better over long-running rollouts because it's going to remember its previous thoughts. It won't have amnesia and forget the things that it did before.
Yes.
At least in the chain of thought as it was thinking.
Exactly. You got that exactly right. In addition, one thing that I almost forgot to mention, because of prompt caching for us depends on the prefix. So the prefix being the same between requests. The reasoning items are actually what part of that input into the prefix. So in addition, you actually get better caching performance. So it's cheaper, more intelligent, and faster.
Awesome. So more cost efficient too.
Exactly. And just to show you guys the verbosity parameter, how it works, we can just run those two requests here. Note any difference between the two, Eric?
Maybe I think the second one is longer.
Oh, yes, absolutely, Eric. You're right on the money here. As you can see here, verbosity steers the final output of the model as well. So in addition to final output, it also affects the tool call as well. So here I have something mocked up. This is a custom tool which allows the model to call the tool in plain text. So as you can see here, this is defined in a very simple way. This is sort of a stand-in for an applied patch tool. Let's say if you're cursor making an agentic coding tool, right? And here I have a prompt, and I'm going to run this prompt in low as well as high. And what we can see here is a little bit of a difference between how the tool call is also emitted. So those are two different code snippets that's emitted. It's a little bit hard to tell between the two, but you can see here that that verbosity high produces a code that's a little bit easier to read, a code that has better error handling, as well as just overall a little bit more readable for developers. And while the first one, low verbosity, is still readable as well as correct, it's a little bit less less readable. So in a case where code readability is important to you, we discovered that verbosity high is actually really conducive to that. So my best advice to you would be experiment for your use case on what sort of verbosity level works best for you, and go from there. And for agentic coding use case, we found that verbosity high works really well. And cool. And then and I have a fun snippet that also ran here. But before getting into this, I would just love to reiterate on the things that I've talked about. the differences between switching to completion to responses API is really, really huge. So I would just love to reiterate on that. So if there's one thing I would like you to take away from this entire build hour, sorry, Eric, sorry, Anoop, sorry, Riley, is use the responses API. Please, please, please use the responses API to use the model in this unhandicapped way. So pass back the reasoning items for maximal intelligence. Other things are minimal reasoning for latency-sensitive tasks, free-form function calling, as well as verbosity parameter for your desired length. And here I have this pretty funny prompt that I just thought would be kind of cool. Like I copy and so this has already generated the code, and I've copy and pasted this code right here. And let's see what it generates. It's wow. What is that, Eric?
So if I'm seeing this correctly, it looks kind of like a creeper, which is an entity like a mob from Minecraft, a game that I played a lot as a kid.
Oh, wow. Okay. Well, great. I played that game a lot as a kid as well. I wonder why this is showing up here. Maybe you have something prepared for us, Eric.
Yeah. So, hey guys, again, I'm Eric. Today I'll be talking a bit about like what we're excited about for from the research side, like to improve in the next iteration of the model. But first, I kind of want to give like a visual demonstration of where the model really shines. So first, we'll be building a Minecraft clone in Codex. So for context, so I'm in my Minecraft folder, which you can see is empty. For context, Codex is part of our coding suite of products. One particular product that we have is Codex CLI, which is a terminal tool where you can do prompts, write prompts, and it'll just output code. So I have a prompt for Minecraft that I will paste in. So this is going to be writing the whole application from scratch. So as we can see, like you're using OpenAI Codex in terminal. We're in our Minecraft folder. Codex is going to have access to all of the files and folders in the folder that we start in. Right now, there's nothing in there, so it's just starting from scratch. We have some commands here. We're not going to use those today. Codex by default uses GPT-5 today. And as you can see, GPT-5 is going to tell us first what it's going to do before it actually goes and does it. So it's thinking, it gives us like some high level plan. And
so this is GPT-5 inside of Codex.
Yes.
How might an audience member here try it out by themselves?
Yeah. So go online and look for the Codex docs. You can find this like on Google, or if you like ChatGPT for it. It's a pretty easy like npm install. Then like as I did here, like you just type in Codex, like it'll give you a nice like little terminal command, and then you get this really nice interface where you can just type in like a chat box, and it'll show you as it runs. So great. So it gave a high level plan, and now it's giving GPT-5 is giving a bunch of checkboxes which it'll run through, and now it's going to run for about maybe like 3 to 5 minutes. So we'll let it run.
Yeah, while it's running, Eric, I have a couple of questions on top of my mind. I imagine probably you guys have as well. What are you most excited about GPT-5, since I think you've been the one training it?
Yeah, I think there's a couple of things that you touched on earlier, Bill.
Yeah.
I think a big focus was agenticness. We want the model to be more coherent over like bigger tasks that take longer, like longer time horizon tasks. So this is something that we really dialed in. I think something else that we really focused on is front end and web development. So previous models were already quite functional, like they thought hard, they can build like very functional applications, but they often didn't have as much of an idea of like taste and an understanding of like what makes a web application beautiful. And so GPT-5 today is, in my opinion, like one of the best, if not the best model for building like really beautiful applications and websites. It's also very steerable, as we mentioned before. So it'll adhere very closely to your prompts. So if you want to change like the way that your website looks, you can do that and just like vibe code and build whatever you like.
That's awesome. That's awesome. And I see that the Codex is running through certain things, and it's almost like finishing up here. It's like checking.
That's quite fast, actually. Yeah. So kind of as we can see, it's giving us. So yeah, we start out with this plan. It's checking off things on the plan as it goes and explaining what it's doing. So the visibility into what it's doing is really good.
I see.
And it's showing us the patches that it's making. And wow, nice.
Wow, is it done?
It's already done.
Oh,
okay.
Shall we play it?
Yeah, let's play it. So what I'm going to do is I'm going to go into my other terminal, which is in the same folder. I can do an ls just to show that now there's files in here, whereas before there weren't. We have some instructions here for how to do this, but we can npm install, which will install some dependencies. Great. And then we can npm run dev to try it. So let's try it. So we'll go into our browser here. Cool.
Wow, this is...
So, okay, interesting. So we have a world here. We can break blocks. All right, so we can make some updates to this. I think that there's a couple of things that we can do. First, I want to customize this a bit to make, the world is a little too green for my tastes. Like it added borders like I wanted it to, but I think it could be a bit more pink.
Yeah.
I think there's also some rendering here. So let's just prompt that. Like the beauty of Codex is that, and GPT-5 and Codex is that it understands your intent and it just builds. So let's give it a pretty meaty prompt actually. Maybe I want to add pink flowers onto all the blocks.
I also want it as a sun.
Okay, let's do that and make the sun a pink flower too.
Yeah.
Also improve the rendering of the blocks.
Awesome.
Cool. And this should run for a little bit. So while it's running, I also want to talk about what we're excited about for future iterations of our models. There's a couple of things here. I think one is continuing to push hard on web development. I think this is like a really big use case and people care a lot about it. So making additionally more beautiful and complex web apps that are just super functional. I think something I'm personally very excited about is models that can work in a loop to iterate on your app. Because right now models are they're confined to just building your app like we're doing here, but they have no real visibility into the application that you're building. Outside of some small cases where it writes some tests. I think the future is models just in a loop, iterating with you, building, testing, building, testing. And I think that this is something that the whole community is going to work on, connecting models to testing environments, and we'll work hard as well to make the models better at this. I think the final thing is just improved agenticness. I think over the medium to long time horizon, in the future, the models are just going to get more and more coherent over longer horizon tasks. And I kind of see a world where there's this agenticness slider. I'm kind of shamelessly stealing this from Andre, but Karpathy, that where the models can do very long horizon tasks, maybe an hour, a day, a week. But sometimes you want them working together with you, in the loop. And I want the models to kind of just understand from context, what you want. Do you want this to be a quick small thing, a minimal implementation, in the coding example, or do we want this to be a very long running thing? Yeah.
Eric, you're really painting a picture of the future here. If I'm understanding it correctly, the future models will be able to better understand if this task is simple or if it's hard, if it needs to think longer, or if it's thinking shorter. And in addition, it's just going to be smarter. And for the longer running task, it can just be so much more agentic. It's be able to do things hours, maybe days on end, if I'm correct here.
Yeah. Cool. I think this is done. So let's... we already have our server here, so as the code changes come in, we can just kind of see how things go. Oh, wow. Okay, that's
a lot of flowers.
That is pretty cool. They actually added the flowers on top of the blocks.
Wow.
And we can actually
jump,
kind of run around and jump.
Oh, wow, that's amazing. Where is the sun?
Where is the sun? Cool. But nice. So that's basically you can continue customizing this. You can add mobs or other mobs are short for mobile entities, I think. So different things that you can interact with. Okay, so to end this, I think I will just jump off the side.
That's wow, that's
cool.
Okay.
All right.
Also, one last thing before we end on this is that in order, I think, Eric, when we improve on the future models, we also want to hear your feedback as well. So we've created a very simple Google form just for you to drop any thoughts that you might have, and this should show up inside of the chat. So feel free to take a look at it, fill it out, and would really appreciate anything. And Eric actually personally.
So I think the thing that the team really wants more than anything else is your feedback. Like, we want to understand your use cases, because I think we try to understand as best as we can, like, what everyone's doing, but there's like so many different use cases. So yeah, we'll send a form. I'm personally going to read everything, and yeah, we'll improve on. We can only improve on stuff that you tell us that is like important to you. So please send us your feedback.
Cool, thank you. I love the pink flowers. I think you guys were inspired from my Barbie GIF. Definitely steerable. So on that note, welcome Anoop. He actually wrote the prompting guide, so he's an expert on prompting. As I mentioned, GPT-5 is really steerable, and so Anoop is going to help you get the most out of GPT-5 with really good prompting.
Yeah, thanks, Christine, and thanks, Bill and Eric, for the awesome demos. Hopefully, we can get you guys to build demos as good as they did with the prompting tips that we're giving today. Sweet. Maybe just like a tangible example of where we've seen prompting actually provide a big lift to GPT-5 performance. Here's one where Alex tweeted, hey, we were previously just took our old prompts and put them into GPT-5 and didn't really notice much results, and maybe even worse results. But then realizing there's some nuances to prompting GPT-5. And once you realize those nuances, you can get a lot better performance that's statistically a lot more significant than what they've been seeing in the past. And if you see the little quote tweet at the bottom, Eric mentions that, hey, GPT-5 interprets your words literally and very, very well, like follows instructions. So like make sure to be specific and make sure the model will understand what you're trying to mention to it in the prompt. And then now we're just going to go over a few different examples actually of how to think about like a prompting cheat sheet. So these are like maybe 6 snippets that we think will be helpful, but obviously there's a lot more that's important when you're working on prompts. And hopefully this is just a starting place to get you to that 80%. And then that final 20%, hopefully you can tweak pretty quickly with the intuitive tips that we're giving now. Cool. So I think the first thing is maybe the most important part for getting the most out of GPT-5 in terms of prompting. We've seen in the past that when folks are using older models, that if you give conflicting instructions or information that's maybe a bit imprecise, the models will sort of vibe and infer their way to an answer that kind of does what you want it to do most of the time, and you're generally pretty happy with it. But the thing we've noticed with GPT-5 is if you also have those same imprecise, like maybe vibey answers that you're looking for, GPT-5 really interprets those like super effectively and maybe to the detriment of performance. And what happens if you read over the reasoning summaries that Bill mentioned with the responses API is you'll see that the model is actually conflicted. They're one part saying like, oh, what's going on in this instruction? And then the other part's like, okay, maybe it's working as expected. So this is a place where we want you to make sure that you don't have any of these conflicting instructions and you have very precise pieces of information that you're giving GPT-5. And that's where we see pretty big step function improvements across maybe previous models that you may be using. So that's the first step. The second one is using the right reasoning effort. We recommend starting with medium, but as Bill mentioned in previous slides, it's probably useful if you want like a low latency task to start with low reasoning effort, or maybe you're running like a super long agentic task like building Minecraft, for example. Then maybe you want a lot longer reasoning effort and maybe you want to turn that to high. And maybe you want to turn up verbosity as well to high for that. This is actually, we ran some tests when we were doing the prompting guide, and we were wondering like what's maybe the best structure to structure your prompts. Is it XML? Is it Markdown? Is it JSON? Is it YAML? Or is it something else? From our tests, we've seen that XML performed the best, but as always, I will always caveat this. There's maybe some things that work well for your use case that might not work for others. So just know that we've seen XML perform the best for our tests. The fourth one is maybe a meta point, which is meta prompting.
I see what you did there.
Thank you. The way to think about meta prompting for GPT-5 and maybe just as a whole for how to improve prompts is generally we've seen people in the past say, okay, X thing is broken in our prompt. Can you please fix it? And maybe the model does okay there, but the pattern we've seen actually do the best, and we'll show an example of this, is actually asking the model why it's doing something. And then once you ask the model why it did a certain behavior, then the model will maybe give back some responses. So GPT-5 will say, maybe I did this incorrect thing because of X, Y, and Z reasons. And then once you have that, then you can ask the model to fix it based on those reasons. So it's a lot more precise in the actions you're taking versus maybe making those like single one-off changes initially are very overfit to the specific prompt where you might not want to do that. Cool. I think the next thing you kind of saw in Eric's Codex demo, right, is give room for planning and self-reflection. The model does this really well out of the box already, but making sure you have some sort of planning or some sort of setup step for the model gives it a lot of room. And we kind of saw that with the to-do list in Codex. And then the final thing, we've kind of mentioned this a couple of times, right? Controlling the agenticness of the model can be a bit tricky. So maybe there's some points where the model is maybe doing too much and you want it to actually defer to the user to give input. Or maybe sometimes it's not doing enough and it's asking the user for input too often. There's this like fine balance you wanna find. And we have some tips here to help you do that in a demo coming up. Sweet. Maybe let's hop into the demos.
Great.
The Minecraft
Yes.
creeper is staring at us.
Yeah, you can build that.
So for the first one, let's actually chat through like controlling agentic eagerness. So right here, I'm gonna plan on building 2 websites. One website where I'm just gonna give a default prompt with a bunch of different examples. So you'll see them here. There's like 15 different elements that I want for this website. And then I'm gonna do the exact same thing with more eagerness. And the way you'll see this is I'm going to scroll past it. But the way you'll see this is we'll add a little persistence check to the model, and then that persistence check will make it go a little bit further for its next steps. So if we want to see how this actually might look, if we run this, so these are just some boilerplate code. Let's run it. And then once it's running, we can see the outputs that we ran. So this is with less persistence. So we didn't ask the model to keep going and go through all 15 steps. We have a website generated here. It has some frequently asked questions, kind of did the task as expected. And then here we have the same thing. It's a little bit more structured and well put together. We have a few different items here. It looks pretty similar, right? All the key parts are there. The main thing I want to call out here, if I go back to the prompt actually, is one of the things we asked for in the FAQ section is add at least 3 common questions in a collapsible accordion format. So there's a lot of small, minute instructions here, right? There's at least three. If we go back, it looks like there's at least 3 in the FAQ for both of them. But the collapsible accordion, I don't know if a plus sign counts as a collapsible accordion, but those are like the small nuances where if you add persistence, this is the icon you would kind of expect for a collapsible accordion folder.
Yeah, in my book, that's an accordion. The other one is not.
Okay.
That's a fake accordion.
Bill Chen approved, so We'll take it. So that's one example of maybe adding persistence to your prompts to actually get better performance out of the model. So the next thing, maybe before we get there, is maybe how do you control having less eagerness in the model? For that, maybe one thing you can do is actually control the search depth, for example. So here's an example where we say, actually we want the search depth to be very low initially when you're like searching for a bunch of things, maybe in a code base. And these are some actions you want to do of maybe you only want to go 2 tool calls to search, maybe not do 8 of them and 8 different greps. Bill, I know you're a big vibe coder, right? Like,
oh, yes.
Have you played around with this and seen it perform well?
Oh, yeah, no, I definitely have. I think the issue a lot of times that I've seen was like the folks is that like GPT-5 would love to get the answer correct. And so at times it sort of has its own agency. So it does a lot of exploration to make sure that the answer is absolutely correct. But for sometimes you actually don't need that much. You don't need all of that, like, context. You also don't need things to be 100% correct. So in those cases, having a prompt like this was really helpful in sort of turning down that the exploration eagerness in the very beginning. So
Sweet.
I have seen a lot of success with this. So I guess I have a question for you. Like, how does like eagerness compare to the stuff about persistence? Like, how do the two concepts differ?
Yeah, so maybe you want more eagerness or like more persistence if you want like these longer tasks to be completed end to end without any user input.
Sure.
And then maybe the user will then change things as they go. But maybe you want less eagerness, for example, if you want the user to say, okay, you want them more brought along in the process, and you want them to give input as it's going along. So you want the model to be more of like a pair programmer's.
I see. So instances where you want the model to be more agentic, or like the other part could be like a trade-off between collaborativeness.
Yeah, exactly. Sweet. So that's like maybe one prompting tip we have. The next one is maybe how you would prompt for preambles. So this is a new feature that we added for GPT-5, where you can actually prompt the model to give explanations for the tool calls it's doing. And you can do something very trite, right? Of in your prompt, just say, before every tool call, explain why you're doing the tool call, and then it will do that. But we found that there's a nice UX you can gather from actually controlling this behavior. And since GPT-5 is a very steerable model, this is a prompt that we typically like, but obviously change it for whatever use case you're working on. We kind of like putting up an upfront plan. So before the model calls any tools, give it a plan. And then as it's calling tools, maybe grouping them together or summarizing them as you're working on each distinct task. So we can actually see this if we go to the playground real quick. And I have a prompt here where we're planning a picnic actually, and we've added this tool preamble, and we've added a bunch of MCP servers of different stores for planning this picnic. And then here I want to actually plan a picnic for all of us in the room here to somewhere in SF. And we want to use all the items from these stores. So let's give it a shot and see what it does. So as this is running, maybe I'll just like walk through this preamble prompt, right? We kind of always begin with like stating the user's goal in a friendly manner. And then once we do that, we want to like outline the structured plan in like some detailed logical step. And then as you see your searches, maybe like do some additional lookups and narrate each step for the user. So right now, you see the model's initially just reasoning and thinking through the prompt as it's given. And then once it's thinking through the prompt, it will start reasoning through and maybe give this upfront plan. So right now it's like understanding the cart requirements and like seeing that, oh, we've given a bunch of MCP servers to the model and see what it does.
So how are you providing all of those tools? Like you mentioned MCP servers. Can you tell me a little bit more about those?
Yeah. So as you can see in the response API, you can add a bunch of separate tools. So obviously we support all our hosted tools like web search, code interpreter, etc., and also custom tools. But now you can also add MCP servers or your own custom functions that you'd like. Yeah. So maybe as this is going and reasoning about its plan, are there places where you guys have seen like preambles do pretty well or like helped you guys?
Oh yeah, absolutely. As you said, I am a big vibe coder. I almost forgot. I don't think I can write code myself like from scratch anymore. I don't even think I can write a for loop anymore. And so like it's really helpful to be able to have a model here that walk you through the different steps on when it's building something, just like Eric has showed using Codex, what exactly it's building, why it's building it. And sometimes actually, if you have done something wrong in the prompt, you can also catch sort of the mistaken reasoning path that's going down using the preambles, and you can also correct your prompt accordingly as well. So that's what I've seen. What about you, Eric?
Yeah, I think this is a really good and like important UX to have. Like in your favorite coding assistant, whether that's like Codex, Cursor, Windsurf, it's really useful just to see like what is going to happen before it happens. And it means that like as we talked about, the models are kind of running longer and longer, and so it's really important to be able to monitor what they're doing as they go, and people can just like stop or pause workflows as they go down the wrong path. So it's like that monitoring is really, really important, and I found that very useful.
Cool. So yeah, as you see here, it gave the plan and then gave its thinking of like why it's calling certain tools each time. And then as we see, this will keep running. But I think the final thing we wanted to quickly show you is how you'd optimize your prompts pretty quickly in the playground itself. So the final example, let's make it pretty quick, is we have this instruction following example here. This example actually has a bit of conflicting instructions, which we'll notice when we put it in to this tool. I'm just going to ask, can you fix the conflicting instructions? And maybe to briefly explain maybe where the conflicting instructions are is you'll see this section right here where it says, always look up the patient profile before taking any actions to ensure that they're an existing patient. But then we have this section here, which is for high acuity orange cases, auto assign earliest the same day. If explicit consent is on file, proceed to book and notify the patient. If consent is unknown, just like book it immediately. So the change we made, if we click it, is clarified the high acuity use cases, and the assistant must tentatively state at the earliest time slot. So this is an example of using meta prompting and using our tools to hopefully help improve your prompts pretty quickly. Obviously, this is a very short example, but we've seen this work pretty effectively for a lot of customers we've been working with. And yeah, with that, maybe I'll pass it off to Christine.
Awesome. Thanks, Snoop. So up until this point, you've heard a lot about coding, tool calling, the responses API. So I'm really excited to bring this to a real world application. A lot of you guys tuning in are founders yourselves. So we'd love to welcome Riley, the founder and CEO of Charlie Labs, on stage with us.
Hey, Christine.
How's it going?
Thank you very much for having me. I'm excited to be here and chat about how Charlie is using GPT-5.
Of course. So I'll let you take it away.
Perfect. I'll jump into a screen share here. Quick intro on myself, just in case you were concerned I wasn't a technical co-founder and you shouldn't trust me. This is my GitHub profile. What's most interesting here is this period here, which is where we got early access to GPT-5, and my productivity personally increased so much that it washed out the rest of this chart, which is pretty wild. And then one other quick note here is if you look at code review versus other over time, and you go back a couple of years, you'll see how much programming is changing. So what is Charlie? Charlie is a TypeScript-focused coding agent, but he's not an IDE or a CLI tool that runs locally on your machine. You interact with him via GitHub, Linear, and Slack, just like you would with any humans on your team. The normal workflow looks something like chatting with Charlie in Slack to brainstorm, moving that into a linear issue, maybe polishing it up, and then asking for a PR, and then reviewing and iterating in GitHub until it's ready to merge. I'm going to do a quick demo as part of this. This is a demo repo of the apply patch tool. So this is our implementation of the apply patch tool that we'll talk about more. This is a Slack org that's hooked up to that repo, as well as a linear workspace. You can see I seeded it here with a couple of questions. So I asked Charlie, read the README and see if there's anything that's wrong or could be improved. Search the repo for bugs and let me know what you find, and look for outdated comments. These are just kind of simple demos so that we can do this in time. If you jump into one of these, you'll see, so this is one where I asked Charlie to look for bugs. He searched through a whole bunch of stuff. Interestingly, he also ran the tests and types and was like, that's all good. And then had a list of things that we may want to fix. So I said, open a linear issue for the normalized method suggestion and another one to handle the case-only file renames that you pointed out. So he did that. This is the issue. One of the nice things about making issues from Charlie is that they look very nice and they're fully written, which I'm sure most of you have never seen an issue from an engineer that looked anything like this. So those messages resulted in these 5 issues, which I'm going to quickly assign to Charlie. And then, so he's going to get started on all 5 of these while we jump into explanation of how Charlie works. So this is GitHub, Slack, and Linear. Charlie receives webhook events for all kinds of actions. And then he also has the ability to write back to those platforms. And when he gets that, he's going to start talking to GPT-5 as the main driver of the agent loop. We are using the responses API, which has worked very well. One of the other nice things about that is that we're using the built-in web search tool, which is also fantastic. Like, that is such a simple add and increases results a lot in a lot of different ways. So then once Charlie's running, Charlie really only has one tool in his agent loop other than the web search tool, which is run a bash command. So he spins up a VM powered by run loop that is set up specifically for writing TypeScript code. So it has a bunch of the dependencies, the tools, and then a normal flow would look something like using ripgrep and sed. If you guys have run bash commands, you've probably seen how much GPT-5 loves using sed. That's going to gather some context. And then we use the apply patch tool, which is a really smart way to edit code efficiently. It works far better than search and replace or rewriting entire files. And then running some tests. Something where GPT-5 really stands out here is if these tests fail, that historically could be quite problematic for models to get thrown off track and being able to backtrack to actually fix it. GPT-5 is really good at kind of recovering from both being smart enough to run the commands and then also to recover from them. And then he'll make a commit and open a PR. A couple other things that GPT-5 really stands out for here is the ability to work with a wide range of platforms, because we're like sometimes he's opening PRs, sometimes he's creating linear issues, sometimes he's sending Slack messages. So there's actually a lot of different commands that can be run here depending on what the user asked for and where the event came from. And GPT-5 does a really good job with that. Quick evals for comparison. So this is our internal PR creation eval, which is like Sweetbench, but actually creates a real GitHub issue and the agent has to create a PR, not just a diff. We saw 16% improvement from O3 using exactly the same prompt. And then after we optimized it, we got up to a 29% improvement from O3, which is pretty awesome because when we switched to O3, we switched from Sonnet and saw a similar size improvement when we made that change. And then PR review eval. So this is, we have a way to evaluate the model's ability to find bugs and also not leave comments that are incorrect or noisy. We saw 5% improvement over O3, which O3 was already pretty good. And kind of to balance that, we ran the evals with Claude Opus 4.1, and it was 46% worse than 5. And because we kind of had to do it, we ran a head-to-head of Charlie versus Claude Code, where we used Charlie. We got 10 issues from open source projects, ran Charlie on them, and then set up Claude Code with the GitHub action so it could generate PRs from those issues as well. And then we use this series of LLM as a judge. You can go to the link here. It's research.charlielabs.ai for more information, but Charlie won 10 out of 10 of the comparisons and scored better in aggregate for testability and quality and description. We've had some challenges with the verbosity. That's been our biggest battle with 5. But overall, really good results. We've been really happy with how Charlie has been working with 5. We can quickly look back and see where we're at here. Okay, so these 5 issues, it looks like we have 4 PRs already. We can jump into one of them. So this is Charlie will open a PR under his account, context on what was changed, how it changed. He's really good about running verification to prove whether the changes actually work. One of the nice things about Charlie is you should be able to one-shot a lot of PRs. Like I don't actually open an editor or a terminal very often anymore because Charlie is so good about making sure that this PR will pass. And then he also will review his own PRs. So he had some advice here. We're not going to have time to see it, but I can say, yes, please to that advice. And then what's going to happen is Charlie is going to go, he's going to get this, he's going to go read this, and he'll push a commit to this PR to fix the issue that he pointed out. And then this is, so there's 4 other PRs that came out of this. It's pretty amazing being able to work in parallel like this. Like I'll often, if I have a bunch of meetings come up, just coming up, queue these up and fire them off. And then when I come back, I have a whole bunch of PRs waiting to be reviewed and merged.
Awesome. Thanks so much for sharing this, Riley. I'm going to drop Charlie in the chat so you guys can give it a try. Really appreciate your time. Thanks a lot.
Perfect. Thank you.
Thanks, Riley.
Thank you, Riley.
Okay, so now we have 10 minutes left for some Q&A. Let's get into it.
Let me actually share my screen once again. Okay. Hopefully everyone can see my screen. And here we have the questions that y'all have put up. So the first one is, what are your best practices for context engineering, especially in the space of coding? Wow, this is a very good question, and I frankly don't think we can, answer it fully in the 10 minutes that we have, and we'll also want to answer other questions as well. But I think I have something on top of my mind. I think perhaps you two can dig into it as well. But for context engineering, especially in the space of coding, this is definitely a really interesting topic. GPT-5, while it performs pretty well across the long context, it still has a fixed context window of 400,000 right now, input plus output. So being able to figure out what parts of what are the things you want to throw in that context is very, very important as well. So we've seen successes with people using summary models that compacts the past parts of the conversation as the conversation goes longer. So the model can focus on the newer and more relevant information. We've seen a lot of success with that. The other part that we've also seen a lot of success with is for the simpler tasks. Actually, our recommendation is just that you can also just toss a lot of sometimes the entire repo in there. That's fine. But for context engineering, when the things get too long, summarizing the older parts of the context, compacting it is the recommended way of going forward as well.
Yeah, my thought here is the models are very good at using tools, particularly even very simple tools like the terminal tool, which is very generic. So another recommendation I have is if you have a full context and a large repo, you can give an outline of the file structure or interesting things that you should look at, and then the model can decide on its own to call tools to find that context. And in combination with summary models or compaction, I think this is very powerful for reducing for using the most effective context that you need.
Yeah, I think +1 on the tools piece and also it's helpful to have a section in your prompt probably around tool decision boundaries, so you can be clear of when you want to grab certain pieces of information for the model.
Yeah, and on that piece, just to double click on that, GPT-5 is very steerable, so it should respect the tool boundaries that you outline very carefully. And then the other part is GPT-5 also excels at parallel function calling. So for a lot of those exploration context gathering parts, make sure that you also put in the correct infrastructure in place to take advantage of the parallel context gathering capabilities. The next question is, how does verbosity affect the instruction I provide? For example, if I ask for a 1,000-word essay and set verbosity low, will it not follow the instructions? That is also a good question here. Eric, I'm wondering if you might have some thoughts here.
Yeah. This is a challenging question, actually. My intuition, I actually haven't tested this myself. My intuition is that 1,000 words is probably short enough that verbosity won't matter too much. I think it's some longer lengths, say you want a 10,000 word essay or even a 100,000 word essay, verbosity will take precedence. I think overall, the hierarchy looks like roughly how I think about it is at verbosity high, there's no limit. And so the model will just follow whatever instruction. But at verbosity low, the verbosity has an increasing effect as the essay that you ask for gets longer, and the verbosity kind of takes precedence, although it's sort of a soft impact on the model. So I'd recommend, if you want this kind of steerability, set verbosity to high and then say what instruction you want for how long something should be.
Yes. So verbosity is a library in the API that you can use, but also at the end of the day, it sounds like the prompting is also highly effective, even if you just set verbosity to high.
Yes.
Cool. Let's move on to the next one. Any tips for generating code while minimizing slop? Wow, slop is a common word.
I love the word slop.
Yeah. What does that word mean? I think, I'm a bit of a previous generation folks. I'm kind of getting old these days. I think a noob. You're the youngest person here. What does that mean?
Yeah, I guess it just means not good code quality. Maybe the tips for generating good code. I think our general advice here is having some sort of style guide in your prompts help the most for minimizing the slop. as the Gen Z people say, I guess, or tech debt. That's the main one. Maybe Eric or Bill, do you have anything else? But I feel like that's the main one, right?
Yeah, I think that's a big one. I think something I do while working with GPT-5 is like give it the feature list that you want and then just say like be minimal. Otherwise, the model's pretty good at doing this, but I think like that extra little reminder does help. Depending on the kind of application that you're working on, this isn't always true. Saying like build minimal tests and like run them, that also helps a lot and like makes the code that it writes like usually like more correct, like more well structured, and just generally improves things.
Yeah, and I think on my part, I don't think I'm the most qualified to comment on this because I kind of embrace the slop because a lot of the things I build these days, that's also another way to go. So one thing is the models will keep getting better, and like these days you call it slop. I think like tomorrow, like the models that Eric has mentioned, like the super agentic models that can take tasks from end to end, that can handle vagueness well. Maybe it's going to generate that like slop that it like should not be called slop anymore. And I think I look forward to that day. But like even today, I think GPT-5 is really good in the sense of following the instructions you give it, so that if you actually just say things like, hey, I want this to be minimal, I want this to be maintainable, it will actually respect a lot of that to write maintainable, readable, correct code.
Yes.
It's crazy how much of a difference a little bit of a prompt makes, right? Yeah. So really calling back to like your point on prompt really makes a difference. Yeah. And how is GPT-5 better for MCP tasks? So
yeah, I can take this first. The model is much better at function calling. We spent like quite a lot of time on this. It should be better at both novel functions that you give it, as well as sort of the like blessed set of functions that everyone uses, like terminal and such. So without going like too granularly into it, I think it's just, it is better is the top line.
Well, I don't think there's anything else to add to it. I guess like GPT-5 is just make your MCP.
Okay. Like I think the point in steerability is also big. I think it's important to like tune the decision boundaries on your tools pretty carefully. Like the model will get pretty close to what you want, but because it's so steerable, it's easy to really dial in that like last bit on MCP and tool decision boundaries.
Yeah, so a lot of times I like double click on the decision boundary part. A lot of times when folks are thinking that the wrong tools are getting called, it also goes back to the prompting stuff, is that you're actually not really specifying the decision boundaries well. And so sometimes the model's default prior behavior is a little bit different from what you think is a best case scenario. It's worthwhile to spend a little time optimizing for it.
Awesome. I think that's all that we have time for this build hour. We tried to get to everyone's questions, but if your question wasn't answered, highly recommend you check out our new developers.openai.com page. We really consolidated all of these resources that you see. I just highlighted a few over here on the right for you. But I will be sending out a follow-up email with the recording and links, so don't worry about writing all of these down. And then also the code repo, so you guys can try everything that we did today. Last slide is just to share our upcoming build hour. September 3rd is going to be all about Codex. You got a little bit of a preview today with the Eric's building Minecraft, but we'll dive a little bit deeper into this. And then definitely bookmark our homepage because we're constantly adding new build hours, and definitely send us your feedback. So with that, thank you everyone for joining, and we'll see you September 3rd.
Thank you all.
Thank you.